Welcome to Sec 1 Geography, Tropical Rainforests, Climate and Location. Before we look at what lives in a rainforest, or how it is being destroyed, or how we should manage it, we need to answer one question. Tropical rainforests cover only about 6% of the Earth's land surface, yet they contain approximately 50% of all the world's species. Half, in 6% of the land. No other ecosystem on Earth concentrates life so intensely. The reason is not luck. It is the equatorial climate, and that is exactly what this video is about. Let us find out why. Let me make this concrete. Take every species of plant, bird, insect, reptile, mammal, and organism that has ever been discovered on Earth. Roughly half of all of them live in tropical rainforests. That is an extraordinary concentration of life in a small fraction of the planet's surface. And here is the key insight. Every single one of those species is there because of where tropical rainforests are located and because of the climate that location produces. The equatorial climate is not just a background condition, it is the reason the rainforest exists at all. Before we go any further, I want to flag 3 mistakes that cost students marks on this topic every single time. Mistake 1, for WA question 1, students write, the rainforest is hot and wet, with no figures. That scores 0. Mistake 2, for WA question 2, students write, clouds form because it is hot, with no mechanism. That also scores 0. Mistake 3, for WA question 3, students write, the climate is good for animals, with no chain. Again, the climate is good for animals, with no chain. We will fix all 3 of these by the end of the video. Here is what the exam actually tests on this topic. Question 1, worth 3 marks. Describe the climate of tropical rainforests. That question needs 3 distinct features, each with a specific figure. Question 2, also 3 marks. Explain the process of convectional rainfall. That needs a causal sequence, 3 linked steps, each causing the next. Question 3, 2 marks. Explain how the equatorial climate supports high biodiversity. That needs a mechanism chain, climate feature, then effect on vegetation, then effect on species. 8 marks in total. This one video covers all of them. Here is our roadmap. Chapter 1 is location, where rainforests are found and why. Chapter 2 is the equatorial climate, the key figures for WA. Question 1. Chapter 3 is convectional rainfall, the step-by-step process for WA question 2. After Chapter 3, we stop for practice. Pause 1 so you can attempt question 2 yourself. Chapter 4 is climate and biodiversity, the mechanism chain for WA question 3. After Chapter 4, practice pause 2 for question 3. Then we fix the 3 mistakes, recap the 5 key things, and you know exactly what to do next. Let us begin. Chapter 1, location of tropical rainforests. Tropical rainforests are found in a specific belt around the Earth, between approximately 5 degrees north and 10 degrees north, and between 5 degrees south and 10 degrees south of the equator. Look at the world map on screen. You can see the forest belt running across Central and South America, across Central Africa, and across South and Southeast Asia. 3 distinct regions. But why only there? Why not nearer the poles or in the middle of continents? That is the next question. The answer comes down to the angle of the sun's rays, what geographers call latitude and solar intensity. Look at the diagram on screen. At the equator, sunlight hits the Earth's surface at almost 90 degrees directly overhead. That means all of the sun's energy is concentrated into a small surface area. The result is intense heating. At higher latitudes, the same sunlight hits the Earth at an angle, spreading that energy across a much larger surface area. Less energy per square meter, less heating. This is why the equatorial zone is so much hotter than anywhere else on Earth, and why the equatorial climate only exists near the equator. So which specific regions are we talking about? 3 main areas. First, Central and South America, dominated by the Amazon basin in Brazil, the world's largest tropical rainforest at approximately 5.5 million square kilometers. Second, Central Africa, the Congo Basin in the Democratic Republic of Congo, the world's 2nd largest. Third, South and Southeast Asia, Indonesia, Malaysia, Borneo, and Papua New Guinea. Now, Singapore sits at approximately 1.3 degrees north. That puts Singapore squarely within the equatorial zone. The afternoon thunderstorm you experience nearly every day in Singapore? That is the equatorial climate at work, and we will explain exactly why it happens in Chapter 3. Chapter 2, the equatorial climate, and the key figures you must know for WA. Question 1. Let us start with temperature. The average monthly temperature in an equatorial climate is 26 to 28 degrees Celsius. But what is more important for the exam is the annual temperature range, the difference between the warmest and coolest months. In an equatorial climate, that range is less than 3 degrees Celsius, almost no variation at all. Compare that to London, where the annual range is around 13 degrees. In an equatorial zone like Singapore, the temperature barely moves through the year. Why? Because the sun stays nearly overhead all year round at low latitudes, the solar angle barely changes, and so the temperature barely changes either. No cool season, no winter, consistently hot every single month. Now, rainfall. Annual rainfall in an equatorial climate exceeds 2,000 millimeters, often 2,500 to 3,000 millimeters. And crucially, that rain falls throughout the year. There is no distinct dry season. Every month receives significant rainfall. Humidity is also extremely high, often above 80%. Why is there so much moisture? The intense solar heating drives rapid evaporation from the ground, rivers, and vegetation. That moisture rises into the atmosphere, condenses into clouds, and falls back as rain. And here is the key detail. All that rainfall supports the dense forest, which in turn releases even more water vapor through its leaves, a self-reinforcing cycle. More rain supports more forest, which produces more rain. Let us look at real data. This is the climate record for Manaus in the Brazilian Amazon at 3 degrees south. Look at the temperature row on screen. Every single month sits between 27 and 29 degrees Celsius. The range is just 2 degrees. That is the equatorial consistency in action. Now look at the rainfall. High rainfall from January to April, peaking at 262 millimeters in March. Then a drier period from June to September, with the driest month, August, at only 38 millimeters. Some students look at this and say, there is a dry season, so this is not equatorial. But look more carefully. August still has 38 millimeters of rain. Temperatures stay high every month. There is no true dry season, just a drier period. Manaus is equatorial. Now let us build the WA Question 1 model answer using those figures. 3 marks, 3 features, 3 figures. Mark 1, average monthly temperatures are 26 to 28 degrees Celsius with an annual range of less than 3 degrees Celsius. There is no cool season. Mark 2, annual rainfall exceeds 2,000 millimeters and falls throughout the year with no distinct dry season. Mark 3, humidity is extremely high, often above 80%, due to intense evaporation and transpiration from the dense vegetation. Notice that every single mark quotes a figure. You cannot score the temperature mark without quoting the range. You cannot score the rainfall mark without quoting 2,000 millimeters. Figures are not optional extras, they are the marks. Chapter 3, Convectional Rainfall. This is the process you need for WA Question 2. Convectional rainfall is the dominant rainfall type in equatorial regions. It is caused by intense solar heating of the ground and the resulting upward movement of warm, moist air. Let us go through the process step by step. Step 1. Strong solar radiation from the sun heats the ground and water surfaces intensely throughout the morning. Step 2. The ground absorbs that heat and warms the air directly above it. This warmed air becomes less dense than the cooler air above it, a key condition for what comes next. Step 3, meanwhile, moisture evaporates from the ground, rivers, and trees, adding water vapor to the warm surface air. By mid-morning, the air at the surface is warm, moist, and ready to rise. Now the second half of the process. Step 4, the warm, moist surface air rises rapidly through the atmosphere. This upward movement is called convection, which is exactly where the name convectional rainfall comes from. Step 5, as the rising air reaches higher altitudes, it cools. As it cools, the water vapor it carries condenses, turning from a gas into tiny water droplets. These water droplets form large, towering cumulonimbus clouds. Step 6. Eventually, the droplets become too heavy to stay in the cloud, and heavy rainfall falls to the ground, typically in the early to mid-afternoon, often accompanied by thunder and lightning. And why the afternoon specifically? The ground needs several hours of morning sunshine to build up enough heat to trigger strong convection. That heating takes time, so the rain peaks in the afternoon, not the morning. For WA Question 2, the exam does not ask you to write all 6 steps in full. It asks you to explain the process in 3 marks, 1 mark per cause and effect link. Look at the causal chain on screen. Mark 1. Solar radiation heats the ground, warming the air above, which becomes less dense and rises rapidly. That is convection. Mark 2. As the rising air cools at higher altitudes, water vapor condenses to form large cumulonimbus clouds. Mark 3. This produces heavy rainfall in the afternoon, often with thunder and lightning. 3 steps, 3 marks. The key is causal language: heats, warms, rises, cools, condenses, falls. Each verb leads to the next. If you use that verb chain, the marks follow naturally. Practice. Pause. 1. Pause the video now. Your question, WA Question 2, worth 3 marks. Explain the process of convectional rainfall. Write your answer before you unpause. Remember, 3 marks means 3 causal steps, each step linked to the previous one. When you are ready with your answer, unpause for the model answer. Here is the model answer for WA Question 2. Mark 1. Strong solar radiation heats the ground throughout the morning, warming the air above. The warm air becomes less dense and rises rapidly. This is called convection. Mark 2. As the air rises and cools at higher altitudes, water vapor condenses to form large cumulonimbus clouds. Mark 3. This produces heavy rainfall in the afternoon, often accompanied by thunder and lightning. Check your answer against this now. Did you include the word convection? Did you name the cloud as cumulonimbus? Did you explain that the air cools as it rises, not just that it is hot? And never write, clouds form because it is hot. That misses the mechanism entirely and scores nothing. Chapter 4. Climate and Biodiversity. The mechanism chain for WA. Question 3. Let us come back to the fact we opened with. Tropical rainforests cover approximately 6% of the Earth's land surface, but contain approximately 50% of all the world's species. Biodiversity, the variety of different species of plants, animals, and other organisms in an area, is higher in tropical rainforests than anywhere else on Earth. Why? Why? WA Question 3 asks you to explain how the equatorial climate produces this result, and there are 3 distinct mechanisms. I am going to teach you 3, so you always have 2 for the exam, even if one slips your mind under pressure. Mechanism 1. Consistent warmth. The climate feature is this: average temperatures of 26 to 28 degrees Celsius with a range of less than 3 degrees. No cool season, ever. Now trace the mechanism. Because temperatures are consistently high, plants can photosynthesize and grow every single month of the year. There is no winter to force dormancy, no cold season to kill back growth, no period where food supply drops to 0. The result? An enormous and continuous quantity of food and habitat is produced all year round. And the effect on species, a vast variety of animal species can be supported because food is always available. That is, WA. Question 3, Mark 1. Mechanism 2, abundant rainfall. The climate feature, over 2,000 millimeters of rainfall annually, falling throughout the year. Plants never experience drought stress. Water is always available. Trace the mechanism. With continuous water supply, dense, multi-layered vegetation develops. The emergent trees at the top, the canopy below, the understory beneath that, and the forest floor at the bottom. 4 completely distinct habitat zones, stacked vertically within the same small area. Now the effect on species. Different species occupy different layers, different food sources, different microhabitats. A bird that nests in the emergent layer does not compete with a frog that lives on the forest floor. More habitat niches mean more species can coexist in the same forest without competing for the exact same resource. That is WA. Question 3, Mark 2. Mechanism 3 is one that not every student knows, and it gives you an edge. Long-term climate stability. The equatorial climate has been stable for millions of years. No ice ages reached the equatorial zone. While higher latitudes were repeatedly frozen and thawed, the equatorial forests remained largely undisturbed. That gave species an enormous amount of time to evolve into highly specialized ecological roles, feeding on one specific fruit, living only within one tree species, being active only at a specific time of day. This specialization reduces competition. When species occupy very different niches, they do not compete directly for the same food or space, and more species can coexist in the same area. Now, WA, question 3, answer template. Right, climate feature, then effect on vegetation or habitat, then effect on species. That chain, every time, no exceptions. Practice. Pause 2. Pause the video now. Your question, WA, question 3, worth 2 marks. Explain how the equatorial climate supports high biodiversity in tropical rainforests. Write your answer before you unpause. Use the mechanism chain for each mark, climate feature, then vegetation or habitat effect, then species outcome. 2 marks means 2 separate chains. When you are ready, unpause for the model answer. Here is the model answer for WA question 3. Mark 1. Consistently high temperatures of 26 to 28 degrees Celsius allow plants to photosynthesize and grow year-round, producing enormous quantities of food and habitat that support a vast number of animal species. Mark 2. Abundant year-round rainfall of over 2,000 millimeters supports dense, multi-layered vegetation that creates many different habitats and ecological niches, allowing a huge variety of species to coexist. Check your answer. Did you name a specific climate feature with a figure? Did you explain the effect on vegetation first, before stating the effect on species? And please, never just write, "The climate is good for animals." That earns nothing. The mechanism is everything. Let us fix the 3 mistakes we flagged at the start. Mistake 1 for WA question 1, writing hot and wet without figures. The fix, always name 3 features and quote a figure for each. 26 to 28 degrees, less than 3 degrees range, over 2,000 millimeters, above 80% humidity. Mistake 2 for WA. Question 2, writing clouds form because it is hot. The fix, use the mechanism. Warm air rises, cools at altitude, condenses into cumulonimbus. The cooling is the reason clouds form, not simply the heat. Mistake 3 for WA. Question 3, writing the climate is good for animals. The fix, write the chain, climate feature, then vegetation effect, then species outcome. These 3 fixes will protect your marks every time this topic appears. 5 things to remember from this video. 1. Location. Tropical rainforests are found between 5 and 10 degrees north and south of the equator in 3 regions: the Amazon, the Congo Basin, and Borneo in Southeast Asia. 2. Temperature. 26 to 28 degrees Celsius, annual range less than 3 degrees, no seasons. 3. Rainfall. Over 2,000 millimeters, year-round, no dry season. 4. Convectional rainfall. Solar heating warms the surface air. The warm air rises, cools at altitude, condenses into cumulonimbus clouds, and produces heavy afternoon rain. 5. The biodiversity mechanism chain. Climate feature, then vegetation and habitat effect, then species outcome. Write that chain for every WA question 3 mark. Here is what to do next. Step 1. Download the free learning pack in the description. It includes the viewing guide, exit ticket, revision note, worksheet A on the Manaus climate data, worksheet B on the convectional rainfall sequence, and the WA practice set. Step 2. Complete worksheets A and B. They will test your ability to read climate graphs and sequence the convectional rainfall process. Step 3. Attempt the WA practice set without notes. All 3 questions, timed. Check your answers against the model answers in the pack. Step 4. Watch video 11, Tropical Rainforest Structure. We go deeper into the 4 layers, plant adaptations, and nutrient cycling. If this video helped, please like and subscribe. And comment below with your WA Question 2 answer. I want to see your causal chain.